All matter is composed of atoms. There are 118 different types of atoms called elements, and atoms can combine together to form molecules. Molecules are whenever we have two or more atoms bonded together. Now, molecules are very small, and so we have different ways to represent molecules. First is what we call structural formulas. Structural formulas tell us the type and number of atoms, plus the arrangement of the atoms in the molecule. So for instance, water has an oxygen and it's bonded to two hydrogens, and these bonds occur because they're sharing electrons. Ethane has two carbons in the very center, they're bonded to each other, and then a bunch of hydrogens bonded around it. Now, structural formulas are very nice because they give us information on the structure of the molecule, and this can be very helpful once we try to understand the properties of molecules. But a lot of times we don't use structural formulas, we'll use molecular formulas. Molecular formulas tell us the type and number of atoms in the molecule, but they don't tell us anything about the structure. Molecular formulas are very convenient whenever we talk about reactions. Now, in a molecular formula, we say, for instance, water has two hydrogens and an oxygen, so we write this as H2O. We use subscripts to signify the number of elements in that molecule. Now notice there's one oxygen, so we could have a 1 here, but we actually omit this, and so it's H2O. So whenever you see an element without a subscript, that's just a 1. Now for ethane, we have two carbons, so that's C2, and then we have 1, 2, 3, 4, 5, 6 hydrogens, so that's C2H6. Now the order of the elements in the molecular formula really depends on the type of molecule it is. Typically, if it's something called a hydrocarbon, that means it has hydrogen and carbon, the carbon goes first. But this will vary from one type of molecule to the other. Now, a key thing with molecular formulas is that all of these subscripts are whole numbers. We can also have more complex molecular formulas. For instance, calcium nitrate here has a calcium in the center, and then on each side of that calcium is bonded a nitrate group. And nitrate, NO3, is what we call a polyatomic ion. It is an ion, a charged molecule with more than one atom. And so nitrate is actually NO3 minus. And so when we write the molecular formula for this, we write it as CaNO3, and we use parentheses here to show that there's a nitrate group. So we have CaNO3, 2. And so when we look at this, we can kind of say, all right, this tells us that we have 2 nitrogens, and then 2 times 3, so we have 6 oxygens in this molecule. Finally, we have what are called empirical formulas. Empirical formulas tell us the type and the ratio of the atoms. So it doesn't tell us exactly how many of each element are in there, but just the ratio of one element to the other. So for instance, H2O, I have 2 hydrogens for every 1 oxygen. Now this is as simple of a ratio as possible. So the empirical formula is still H2O. But for C2H6, we have 2 carbons for every 6 hydrogens. Notice that both 2 and 6 are both divisible by 2. So I can take this and I can get that this is the same as a 1:3 ratio. And therefore, the empirical formula for C2H6 is CH3. Now, empirical formulas are very useful because they are what we find a lot when we do experiments in the lab. Empirical is just another word for another name for experimental. Let's look at one more. Butane is found in disposable lighters and has this structural formula. And so if I want to go to the molecular formula, I count up the carbons. So 1, 2, 3, 4. So it's C4. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. And so that is my molecular formula. This tells me how many carbons and hydrogen are in there. Now, if I want to go to the empirical formula, what I want to do is I want to look at this and I want to say, are any of these, are they both a multiple of the same number? And both of these are multiples of 2. So I can divide both these numbers by 2 to get C2H5. This is the empirical formula. Now, you may look at this and you say, hey, why can't I just divide by 2 again and get CH2.5? Well, the key thing is with empirical formulas and molecular formulas, we always want whole numbers. So we don't do this step, and we just leave the empirical formula as C2H5. All right, so we have these 3 representations: structural formula, which tells us the arrangement; molecular formula, which just tells us the elements in there and the number; and then we have the empirical formula, which tells us the ratio. Structural formula gives us the most information, empirical the least information. But most of the time in this class, we're going to be using molecular formulas because this is very convenient when we start looking at reactions.